Hey guys, the last section of this chapter is referring to another discrete random variable which is called geometric distribution. Now as you can see here, as you go through your notes, the idea of a geometric setting is binomial, meaning it has that two-ness idea, but here there's no set number of trials. We keep doing until, and that's the golden word, until we are successful. So as you look at the idea of bins, it is going to be two-ness, so it's binary. It is going to be independent, but you notice I crossed this out because there's not a fixed number of trials, because how can it be if we keep going until we have been successful? So our conditions and assumptions are the same as it is for the binomial. And I said something, so I want to restate it. Geometric distribution is like binomial. It is not actually binomial in itself. Okay, so here it has two-ness, so the probability of success or failure. Here, independent, one is not affected by the other. Okay, the fourth one is the probability of success is going to be the same throughout, but as I look at this right here, we're going to keep trying until we're successful. And once we're successful, okay, drop the mic. I'm trying to drop the mic, people. Can't do it. Okay, now, we talked about in class today the idea of how to find the probability of something occurring using the geometric without the formula. But here is the formula for those of you who are creatures of habits. So the bottom line here is that here the probability where K is when it occurred, when we are successful, we keep trying and trying and trying until here K is equal to R, and that is a U, success. So we failed, and then we finally are successful. So another way of thinking about it is, like I said here, instead of utilizing this formula, you keep failing, and then finally you succeed. Okay, drop the mic. Somebody got to buy me a microphone for Christmas. One of those little play toy ones. Now, if you remember the example we gave the example in one of the two classes here for the AP Physics. Someone told me that I think this was period 3, the pass rate for the AP Physics is 20%. So let's say we had a sophomore that took AP Physics. He was brilliant. Unfortunately, didn't pass the test. Okay, a junior, again, took the AP Physics test again, didn't pass it. Here's a senior. He took it, finally passed it. Okay, now this isn't a really bad scenario, but I'll find another one in a few minutes. So he failed, and then finally on the third try, he passed the AP test. This and that, which means the probability of him being successful and passing the test on the third try is 12.8%. Okay, now I want you to take a moment to look at problem number 98 in your book. If you turn to page 20 of your notes, it's not there, so just fill it in right here on the side. So we are looking at the probability that, first of all, it takes some 20%, that it starts 20% of the time. So we want to find the probability that it takes him exactly 3 pulls to start the mower. So here, the word exactly is used geometrically because here he failed, and then finally on the third time failed, and the third time, he was successful. So let's make a note here. The probability of his success is 20%. The probability of the failure is 80%, which means here, and here, he failed, and then finally he passed. Okay, and then you do the math. And it just so happened that these probabilities are the same as the problem I just did. Now let me use that formula that I really rarely use. But what is it saying? It's saying 0.8 to the 3 minus 1 power, then times 0.2. So here is your math, but the reality is, why memorize a formula that is not given to you on the AP test when you can just simply do it using logic? We're going to do problem number 97 tomorrow in class together. Now, go back to your page 19 of your notes. And as we wrap this up here, what is meant, or what do we mean by the expected value of a geometric random variable? So remember, if it's geometric, it's binary, so we have two-ness, it's independent. We have the probability of success is the same, but we stop once we are successful. So here is our probability. So the expected value for the geometric is simply, as we see here, 1 over the probability of success. So the expected number of trials it takes to get to be successful. So as I go back and look at problem number 98, and I'm going to put 98 down here because I really don't have much room. If I wanted to know how many people do we expect, or how many times do we expect to pull before we actually are able to start it. So here, the expected value of y is going to be 1 over the probability. So we're talking about we expect it to be 5. And as I interpret this, it's going to take 5 times. 5 times on average to before the lawnmower works. Okay, so I'm done. I will see you guys tomorrow. Have a great evening. And remember, guys, check Remind to see what the rest of your homework is. Bye-bye.